Okay, this is Mr. Joyner, and this is your assignment for the day. First of all, go into your teams and select your particular class team, and then you'll scroll to the top and click on Class Notebook. And this is all going to be for the warm-up. Then you click on that purple arrow, and then here, Content Library, where you find most of the stuff I kick out to y'all. You'll see there's Lesson Planner if you want to look at that to see what's going on the rest of the week, and also warm-ups. That's what we're going to right now. Warm-ups, you find today's date, which today is the 15th, and here is the warm-up. Picture a glass of ice water. The ice floats, and you know the ice will eventually melt if you left long enough at room temperature. When the water changes from solid to liquid, does the composition of the water also change? Explain your answer. So repeat that last question in your write-up and then explain your answer. You'll save these warm-ups all on a Word document, and then later on at the end of the week, we'll turn them in on Friday when I kick that assignment out to you. Now to what you'll be turning on today, you'll be turning in notes for the lesson. I know I normally wait till Mondays to turn in notes, but with the remote learning, we need to just do it every day, or some assignment every day. Most common substances exist as solids, liquids, and gases, so we're talking about properties of matter, which have diverse physical and chemical properties. So we'll focus on physical and chemical properties. Don't confuse that for physical and chemical changes. We'll talk about that, the changes, later. So what are the things we want to answer is what are the characteristics that identify a substance? What distinguishes physical properties from chemical properties? And how do the properties of the physical states of matter differ? And just like in the lab that we just did, we looked at one of those properties, and that would be density. So we'll be mentioning that again. One of the vocabulary words I definitely want to focus on is this word vapor. It's not common uh, to a whole lot of people when I start mentioning that. I think there's different uses for that word or something like that that often genders confusion. So when we get to that, I'll point that out. Extensive and intensive property are often new vocabulary words that I notice students struggle with. And then comparing physical property to chemical property and not confusing that for physical and chemical changes. One of our old vocabulary words is density. We're bringing that back. That is a property of matter. What I need you to do is write down what a substance is. Matter is anything that has mass and takes up space. So write that down. Matter is everything around us, and matter with a uniform and unchanging composition is a substance. So the main thing right here, substance is matter with a uniform and unchanging composition. So much of our chemistry course will be focused on the composition of substances and how they interact with each other. Can you think of things that would not fit that definition? You would not consider it matter. That's right. It will be things like light, energy. Some states of matter, get these definitions of, I'll have the three main ones that you need to get. Solid, which are a form of matter that have their own definite shape and volume. The key right here is definite shape, definite volume. Notice how it's packed tight right here and how it takes up its own shape. It's not all taking the shape of the container. It's not taking, you can't take the volume from the container. You have to put a ruler along the sides or something like that to get the volume of this solid. It's not, doesn't have anything to do with the container it's in. Then liquids are a form of matter that have a definite volume but take the shape of the container. So they're the same with a solid because they have a definite volume, but they're different because they take the shape of the container. You can see in this picture All the molecules are just spreading out and touching all the sides of their container for a liquid. Again, the states of matter, the physical forms of matter, can either be a solid, liquid, or gas. These are all called states of matter. And gases has no definite shape and no definite volume. So no shape, no volume. They expand to fill their container. So you see the molecules are bouncing around, hitting the sides of the container. So no, you can't take volume there because they don't settle down. They're all over the place, and they take the shape of their container. So they really do not have a definite shape. One of the ones, like I said, I want to mention vapor here. Vapor refers to the gaseous state of a substance that is solid or liquid at room temperature. Can you think of some examples? Yes, that's right. Liquid vapor, steam is a vapor. So that room temperature, water is a liquid, and you boil that so it's above room temperature and turns into a vapor. But also dry ice, if we're talking about the solid here, it sublimates into a vapor when it gets above the room temperature. So you saw in that video that there was one more state of matter that they introduced, and that's plasma. And plasma, basically, it's so high and energetic that all the electrons are stripped away from the proton and neutron, from the atom itself, that that it that it's in a whole different state of its own, high energy state of its own. And you can see some of these things on Earth, like for instance, take a if you were to take a grape and slice it in half and leave some of the skin there, and you left that in a microwave and you turned it on. Don't do this too much or you ruin the microwave. But if you did that, you would see a plasma arc. Or when you're doing arc welding, you see that plasma, those high energy ions. So just mentioning that most of the universe is actually in the plasma form is pretty interesting. The physical properties is a characteristic that can be observed or measured without changing the sample's composition. So you can see here that there are some things you can observe without changing its composition, like oxygen is colorless. It's a colorless gas. You can see that's in the gas state at room temperature. Mercury is silver. It's liquid at room temperature. Water is colorless. It's liquid at room temperature. Sucrose is white. It's solid at room temperature. And sodium chloride is white. It's solid at room temperature. We could mention their melting points and their boiling points and their densities. We can discover all of that and measure all of that without changing what it is, its composition. Now, notice here, well, what about melting and boiling point? Well, yeah, I can change its state by melting it or boiling it. Go from, for instance, down here, go from a solid to, by melting it, turn it into a liquid. If I got it even hotter, get it to the point of it get to the point of it being a gas form. Same thing with ice. I mean, you find it in all three states, but really it's still water. It's just water in a different state, either gas, solid, or liquid state. So that would any state changes, going from gas, solid to liquid, any state changes is still going to be a physical change. And so if I'm saying it's solid, liquid, or gas, I'm saying that's a physical property. So these are properties you can observe without changing it. That brings us to those two funny little vocabulary words, extensive properties and intensive properties. Extensive properties, get this down, such as mass, length, and volume are dependent on the amount of substance present. So you may need to pause the video throughout and or go back to get these vocabulary words down on your notes to turn in. So with extensive, again, it's dependent on the amount of substance. So you could think of things like, for instance, mass. Well, the more you have, the more massive it's going to be. You can think of things as length. The more you have, the more area it's going to take up. So length and volume. These are extensive properties. Intensive properties, get that down also, such as density, are dependent on what the substance is, not how much there is. So why is, density has mass and it has volume like in extensive properties, but when you put the two together and create a derived unit, then it doesn't matter whether the object is large or small. If you increase the volume, like if we increase the number of pennies, well, we are also we're increasing volume, but we're also increasing mass. In since they're inversely proportionate, as mass goes up, so does volume. So mass divided by volume, well, the density stays the same. The density of the penny is still, it's not more dense or less dense just because you have more of them. So it doesn't suddenly become able to float, or it doesn't suddenly sink when it wasn't sinking before. So that's how they can get these big giant ships out there that are made of metal floating on water, because they're able to increase volume without increasing mass. They have a lot of hollow spots. Next is chemical properties of matter. That's the ability of a substance to combine with or change into another one or more other substances. That is called a chemical property. Get that down. Uh, Examples include iron forming from rust, copper turning green in the air. So you've seen that before. You've changed the iron into something different by oxidizing it. So because of oxygen, iron rusts. Copper turning green in the air is actually a type of oxidation but this type of oxidation actually makes it, it's called tempera, and it makes it stronger. Interestingly enough, that's why the Statue of Liberty is green, because it was originally made of copper and it turned green. How about observing these properties? A substance can change form, an important concept, and this is an important concept in chemistry. Both physical and chemical properties can change with specific environmental conditions such as temperature and pressure. They've been playing around with this with they're just still discovering new properties of water under different extreme temperatures and pressure. So let's list some physical properties, stuff again that you can observe without changing it. The physical properties of copper are reddish brown, shiny, easily shaped into sheets, which the word we use for that is malleable, and it can be drawn into wires, being like stretched out into wires, which is good because we use it for our wiring. We call that word ductile. A good conductor of heat and electricity, which makes copper supreme for our electrical wiring. Density equals 8.96. We can talk about its boiling point. We could talk about its melting point. And then how about compare that to the chemical properties? Yes, copper has chemical properties, but again, these are properties we can only observe if after we've changed the composition of the copper. So we've turned it into something different. For instance, it forms green copper carbonate. So it's become something different, copper carbonate compound when in contact with moisture in the air. It reacts with nitric acid and sulfuric acid, forming a new substance. There's the key. New substances like copper carbonate or something else is formed, that's a chemical property. One type of compound forms a deep blue solution when in contact with ammonia. So let's review what we've learned so far. What are the characteristics? So you'll write the question down, you'll write your answer off to the side. What are the characteristics identify what characteristics identify a substance? That's right, they're physical and chemical properties. What distinguishes physical properties from chemical properties? That's right. The main one that I've noticed is that physical properties you can observe without changing the composition at all of the compound or element or whatever substance you're looking at. Whereas in chemical properties, you can only really observe those properties if you change that substance and its composition. We're not talking about like state changes. That would be back to physical properties. And how do the properties of physical states of matter differ? So how does a solid differ from a liquid, differ from a gas? That's right. Uh, for instance, solids and gases. A solid has definite shape, definite volume. Gases don't have definite shape. They don't have definite volume. Whereas a liquid, it's in between those two. It has a definite volume, but not a definite shape because it takes the shape that it's taking. Very good. So remember, watch the video, write down your notes, turn your notes in as a Word document. Thank you.